All right, like I said, the first one, hopefully you don't need your calculator for. 1/2 is the same thing as 0.5. What's root 2 divided by 2? 707. And root 3 divided by 2? 0.866, 0.87, depending on what you rounded to, right? Okay? All right, so reminder, okay? Very first thing that we want to do is we want to graph the sine curve using the unit circle, very similar to that little GIF that I just showed you, okay? So think about this, okay? What is sine of 0 degrees? Okay, so your x-axis is basically your radians or your degrees, okay? And then this is your y value, that's the result of that, okay? So remember that sine is always your y value. So if we went around the circle, okay? Let's start with 0 degrees or 0 radians. What's sine of 0? What is it, Dan? It's your y value. 0, okay? So we've got 0, 0, okay? If we want, what we can do is we can skip to pi over 2, okay, for now. So what's the y value at pi over 2? 1, okay? So we've got that point. So now, if we were to take all the ones in between, so at pi over 6, let's see, this is what? 3 pi over 6. So pi over 6 would be 1/2, and that would be right there. Nope, be 2.5 boxes. It'd be like right there, okay? So that'd be pi over 6 would be your 1/2, right? Okay, and then you've got your pi over 4, which is root 2 over 2, okay? So pi over 4 is going to give us a 0.707. So right about there, okay, and then you've got at pi over 3, which gives us a root 3 divided by 2, or 0.866. Pi over 3 is probably right about here, okay, and so now you can see our curve is doing something along that lines, right? Okay, but then what's going to happen is all of our y values, okay, all of our y values are going to do the same thing in reverse, and it's going to get us eventually back down to 0. And then we're going to have the same y values, but this time they're all going to be negative until they culminate at a -1. So we're going to have our sine curve come down like that. And then our y values are again going to work in reverse and eventually get us back up to this. So all we're just trying to show there is how we can use the unit circle to create our sine curve on the xy axis. Now, for what we are eventually getting to, it would be very helpful to know the 4 major points. So please make sure you know these 4. That will help. And the reason is we are eventually going to talk about changing the period length. So instead of a sine curve finishing at 2 pi, it's going to finish at pi, or it's going to finish at 3 pi. Okay, and then we're going to do phase shifts. Phase shifts means that we're going to make it move left and right. So if we know these 4 basic or 5 basic points with 0, 0, this is going to help a lot. Okay? Questions on creating the sine curve? All right, so then page 2. All right, up at the top, all I did there was show you that you got your sine curve and your cosine curve. Notice that the cosine curve starts at the point 0, 1, because think about in terms of, you know, your unit circle at 0 degrees or 0 radians, your cosine value is the x value, well, that's 1. You could say that the green curve, the cosine curve, is a phase shift. So it's a shift of pi over 2 of the sine curve. Okay? So just understand that idea. Everything just kind of got shifted a little bit. All right? All right. So, showing your sine curve here. Okay, similar to what we drew on the front. if we were to come up with the y values based upon this graph? What is the y value when your radian measure is 0? 0. What about when it's pi over 2? Pi. 3 pi over 2. Negative 1. 2 pi. 0. Okay, we're going to do the same thing with cosine, then we'll talk about patterns. All right, so cosine. What is the y value when your radian measure is 0? 1. Pi over 2. I think I heard a 0. Pi. Negative 1. 3 pi over 2. And 2 pi. All right, patterns. What do you see for both of them? Something simple such as alternating between ones and zeros, yes? Okay. Notice too that, wherever it starts, it finishes. Wherever it starts, it finishes, okay, because it has to get back to the beginning. All right, so just little things for you to notice, okay? All right. I kind of talked a little bit about the amplitude and the period length when we were looking at the EKG. So understand period length is the time it takes to complete one full cycle. Okay, after that it just repeats itself over and over and over and over again. Okay, and amplitude is the distance from the midline of the graph to its highest or its lowest point. You see both examples here of that in the picture below. Notice that a period length goes from, how long does it take to get back to the top of the hill? Well, that would be one period length. Your amplitude is from your midline and then your height up or your height down, one or the other, okay? If the midline is not the x-axis, I am going to talk about how you can use the idea of the height of the entire curve and divide by 2. The reason we're dividing by 2 is for the top and the bottom, okay? So like if this was, say, 16 and this was a 4, 16 minus 4 is 12. 12 divided by 2 would be a 6. So our amplitude height would be a 6, okay? And the reason is our midline is at 10. Well, notice if I go up 6 from 10, I get to 16. If I go down 6 from 10, I get to 4. So if the midline is not at 0, another way to figure out amplitude is just to take the entire height and divide by 2. Okay? So just showing you two different ways. Questions on understanding period length and then amplitude. Okay? So then practicing with it. First example. What's the amplitude? How high up is it going or how low is it going? Amplitude will always be a positive number. Okay, for what we're talking about, because we're talking about its height. Yeah.
80.
What did you say?
80.
80. Love it. Okay. Would you agree that it's reaching a height of 80 or negative 80? All right. Period length. When does it get back to negative 80? How long does it take?
150.
About 150. Okay. So one period length is about 150. Okay. If you looked at 2 period lengths, it looks like it's about 300, so 300 divided by 2. So period length is 150. Okay? Number 2. What's the amplitude? 2. Notice it's going up to 2, okay, and it's going down to negative 2, so your period length is 2. If I use that other idea, the entire height is 4 divided by 2 is 2, okay? Period length. Well, it's starting here. How long does it take to get back to there? Pi over 2. So if you're having trouble with this, remember amplitude is based upon the y-axis. Period length is based upon the x-axis.
What is the period for this?
That one we said was 150. Do you understand why it's 150?
Yeah, because of this in the middle.
Well, it's basically what it takes to get back to that middle part, right?
Okay.
Okay? All right, so this one, amplitude. So now notice that your midline is no longer at the origin. So this is a situation where if you wanted to, you could figure out the height of the whole thing. What's the distance from 5 to 15? 10 divided by 2 is 5. Otherwise, what's the distance from 10 to 15 or 10 to 5? Hopefully you're going to say 5. What's the period length? What? 20. Okay? We took from here to here, looks like it's 20. Questions on that? So reminder, amplitude is based upon the y-axis, period length is based upon the x-axis. Okay? Last page then. All they want us to do is take our cosine curve, and they just want to graph it from negative 2 pi all the way to 4 pi. So we're basically, if you think about the period length of cosine to be 2 pi, we're going to graph three cosine curves. Okay? All right, so the first question is, where do we start? What is cosine of 0? Lauren? 1. Okay, so we're going to start right there. Okay? What is cosine of pi over 2? What's cosine of 90 degrees? It's up on the positive side of the y-axis. 0. What's cosine of pi, or 180 degrees? So if you need to, like in terms of picturing in your mind, we started here. Remember that it was 0 comma a number. Then it went to, sorry, it was 1 comma number, 0 comma a number. And now over here at 180 degrees, what's the x value? Negative 1. Okay, so we're now down here at negative 1. And then when we get to 270 degrees, or 3 pi over 2, it is what? What's the x value? 0 again. So we're there. And then when we complete a full circle, we're back to 1. Okay, that's 1 period length. All right? So in terms of our x-axis, it looks like every other is a pi. So this is 2 pi. That's 1 period length. So here's our cosine curve. Okay? So this is going to be 3 pi, and this will be 4 pi. So if we continue the pattern, it looks like it's back to 0, then to negative 1, back to 0, up to positive 1. So like our chart from the other page, remember we said it was always alternating between 1s and 0s. All right? They did want us to go all the way back to negative pi. So if this is negative 2 pi, sorry, negative 2 pi. So if I were to extend my graph, where would be the next point to the left of the y-axis? Where should I put my next dot? Anybody? Eric? At 0, so it's right here. The next one will be at negative 1. Then we're back to 0. And at negative 2 pi, back to 1. Okay, so it's basically your cosine curve just in reverse. All right, so reminder, your amplitude, okay, amplitude is equal to 1, and then your period length is 2 pi. Here's a 2 pi, and then here's another cosine curve of 2 pi. All right? All right, so last thing to think about is based upon the graph that we have here, give me a situation in which our cosine curve is increasing. Give me an interval value. From what to what? From pi to what? From pi to 2 pi, okay? So when it is greater than pi, and less than 2 pi. When else is it increasing? So she gave us this one. Yep. All right, so from negative pi to 1, you mean, give our interval is the x-axis. So from negative pi to, there you go. Okay, so she gave us this one. One more? Yep. From 3 pi to 4 pi. Notice that the left side of these intervals are odd, the right side is even. Okay, something to kind of think about. Other questions that you're going to be asked, you know, like in terms of the homework would be like, when is it decreasing? Use the same train of thought. Remember that your interval values are always based upon the x-axis, okay? Questions?